Good morning, everyone. Am I
Good morning, sir.
morning?
Yes,
Okay. So, in the last class, we're discussing about transition graph. Okay. And today, the next topic is transition table. So, in the last class, I gave a simple overview of transition table. That means what is transition table and how we can identify it. Okay. So, before going to start today's class, so let me know. Whatever we have discussed till now, do you have any confusion regarding any topic which have covered till now? Anyone? Any confusion regarding any topic? Anyone? Any query till transition graph? Do you have any query? Yes or no? If yes, let me know about your query. If no, then I'll proceed to the next topic. Hello? No response?
sir.
Yes, Ankumani?
No doubt, sir. 89%.
David? David Remo?
Yes, sir.
Respond in the chat box. David Remo? Do you have any confusion? Zitul, everyone responds. Do you have any doubt or not? Everyone respond in the chat box immediately. Okay, I think most of the students response is no. That is very good. Uh, okay, then uh, start with the next. Start with the next topic. This is called transition table. So, as I mentioned in the last class, that we can represent the DFA by two notation. One is called transition table, one is called transition graph. Till now we have discussed transition graph. That means we use some symbols, we use some arrows to represent the transitions from one state to another in transition graph. But in transition table we are using some statements. Okay, not exactly statement. We represent the data in a tabular form, and which indicates the current state, the next state, and the input symbol using which we can move to the next state. Okay, let me share my screen first. Is my screen is visible?
Sir.
Okay. So in this in this Word file, we have two type of representation of the same thing. In one, we use to represent data in a tabular form, and in the second one, we use some symbols to represent the same thing. And in the both way of representation, what we highlight what is our current state, what will be our next state, and what is our input symbol to reach the next state. Okay, and the way in which we use the tabular form to represent the data is called transition table. That is this one called transition table. And the way in which we use some symbols, we use graphics to represent the transition is called transition graph. Okay, so let's start with the transition graph. Suppose in this graph, oh, insert one shape, this one means this is the, we have to indicate what is our start state. Wilson, can you identify the start and end state of this particular transition graph? Reply in the chat box immediately. Wilson, start and end state of this transition graph. Quickly. Q not start. Yes, and end state or final state. Taking too much time. What is the end state or final state of this transition graph? Tridip, what is the final state? Give your response quickly. Tridip, Q2. Why Q2? Because we have indicate the Q2 within the double circle. Wilson, what happened? How Q1 can be the final state? Sider, can you tell me the input symbols of this transition graph? Mention the input symbols immediately. Sider Sheikh, AB. Can anyone tell me a string which is accepted by this particular DFA? Can you configure a string which is accepted by this DFA or transition graph? A Zitul AAB AAB. Okay. AAA. Okay. BA BP. Okay. That means we have to start from our start state. We have to do the traversal. Okay. And we have to reach the final state. This is all about transition graph. Now transition table. That means we are representing the same thing using a table. How we can do that? In this particular table, first row, the first row indicates the input symbols. Okay. In this transition table, the row represents the input symbols and the columns represent the states. That means, and this arrow indicates Q naught is the initial state or start state. This star represents Q2 is the final state. Here we use double circle to represent final state. Here we use star to represent the final state. Okay. Okay, let me in. Now he can join now. Okay. Now how we can explain the whole table right now? Suppose we are starting from Q naught. We are using the input symbol A, then we'll reach Q1. This is our current state. This is our input symbol and this is our next state. Similarly, in here so Q naught using A, we're reaching Q1. Similarly, Q naught current state, if we use input symbol B, we will reach Q2. Similarly, Q1 B Q2. In case of Q1, from Q1, if we use input symbol A, we will reach Q2. Similarly, Q1 A Q2. Then again Q1 B Q naught. Q1 B Q naught. Okay. In case of Q2, it is a self loop. That means from Q2 using A or B both, using either A or B or both, will reach the same state. That's why Q2 A Q2 Q2 B Q2. That means we are representing the same thing, but the way of representation is different. In one we use graphics, in one you use some tabulated data. So everyone write the definition of transition table. Did I give the definition of transition diagram notations? There are four points. Transition diagram notation. Transition diagram notation. Did I give the definitions? Someone respond. Okay, right then. From this, simpler notations for representing DFS. Right. Simpler notation. Simpler notations for representing DFS. There are two preferred notations. There are two preferred notations for describing automata. There are two preferred notations for describing automata. Number one, transition diagrams. Transition diagrams. Number two, transition table. Okay. Now write number one, transition diagram notations. A transition diagram, right under transition diagram notation, a transition diagram for DFA, a transition diagram for DFA, comma, write M equal to, write the five tuples of DFA, that is capital Q, then sigma, then delta, small q naught, then F. A transition diagram for DFA, comma, M equal to, write the five tuples of DFA, is a graph defined as below or defined as follows. Number one, for each state in capital Q, for each state in capital Q, there is a node represented by a circle. There is a node represented by a circle. Number two, for each state small q, in capital Q, and each input symbol small a in sigma, that is comma, right? Let delta within first bracket, right? Small q comma a equal to p. I am sharing in chat box. That means small q means an individual state which is within capital Q, which is a combination of states. Similarly, sigma is a collection of input symbol. Small a is a specific input symbol. That means for each state small q in capital Q and each input symbol small a in sigma, comma, let delta, that means the transition function q comma a equal to p. That means p is the next state. That means if q is our current state and we are applying input symbol a, then capital P is our next state. Okay, that means if we write here is a q and a, then it will be like p. Next point, if any state small q in capital Q, if any state small q in capital Q is the starting state, Jitul, which one need to repeat? Point B or C? C. Okay. So, point C. If any state small q in capital Q, if any state small q in capital Q is the starting state, is the starting state, then it represented by then it represented by the circle then it is represented by the circle with arrow mark. That means if Q is a starting state among all the states, then we are representing this Q within a circle and using a arrow mark. Okay, then the last point, nodes corresponding to accepting state nodes corresponding to accepting states within bracket, right? Those are in F. F means final. That means the states which are considered as a final state of this transition diagram. Within bracket, right? Those are in F. F means final state, because F, the tuple F represents the set of final states. Within bracket, right? Those are in F are marked by the double circle. That means this one. Hmm? That means whatever we have discussed till now, just it is some point-wise explanation of this. That means when we are drawing a transition graph, we have to remember these points, and accordingly we have to draw this. The next one is transition table. Right, quickly. Transition table. Take the screenshot of this, and later you write this, draw this transition graph as well as the transition table under its definition. Okay, now write transition table. A transition table is a conventional a transition table is a conventional tabular representation of a function like delta, that takes two arguments and return a state. That takes two arguments and return a state. Okay, full stop. The rows of the table correspond to the states That means this one, the rows, these rows, and the columns correspond to the input. This one, this column. The rows of the table correspond to the states, comma, and the columns correspond to the input. Full stop. After full stop, right? The entry for one row corresponding to a state Q, the entry for one row corresponding to state Q, the entry for one row corresponding to state Q, and the column corresponding to input symbol A. The entry for one row corresponding to state Q, the entry for one row corresponding to state Q, that means small q, corresponding to state small q, and the column corresponding to input A. Corresponding to input A is the state delta within bracket q comma A. I am sharing in the chat box. Write like this, and after that you have to, for example, you have to draw this table. You have to draw this. Okay, this is all about representing the DFA. Now, from the next class, we are discussing about the language of DFA, designing the DFAs which accept some strings of some specific languages, etc., etc. Okay, so in the next class, we'll continue the topic called the language of a DFA. Any query? Anyone? সবে ক্লাছৰ ৰেটিংছ বিলাক দিব পাৰি আছে নে? এভৰিৱান ইজ এবল টু গিভ দ্য ৰেটিংছ? সবে পাৰি আছে নে? CBCS no, well, no update means Wilson.
Sir, they haven't uploaded the classes. Just
Okay.
one.
They have not uploaded. Which course you have opted for CBCS?
Physical wellness.
Physical wellness. Okay. Anyone else who are facing any problem? No. Okay then. For today, I have ended this class. But tomorrow we'll continue with just next topic. Thank you.